All right. Hello, guys. Hello. All right. What is a QA Crucible? It's really just kind of a cool name that we came up with for one of our new processes at our startup called Sensu. We're a really small company. We have, I think, maybe less than 30 people, so a lot of the problems I'll talk about today are a little evident of that. So let's... All right, cool. Well, like that awkward video told you, I'm Nikki. I'm going to be standing up here for the next 40 minutes, so I figured I'd let you in on a few personal facts about myself. Like I said, I play beach volleyball, I love fine wine and cheap beer, and I'm a mom of 2 months. But this is also the slide where I'm supposed to tell you why I'm the right person to be giving this talk. I previously worked for the power and performance team at Apple, where I maintained large-scale automation frameworks for performance testing. And currently, I'm a software engineer at Sensu, where I spend the majority of my day designing and coding our product in Sensu Go. However, given my history, I consider QA one of my specialties, even in a developer role. So I'm constantly trying to improve it in our development and DevOps workflows. So before I dive into that story time, I want to explain what Sensu is for context, because I'll be talking about our internal processes for both QA and releases, in addition to some use cases with how our product has some overlap with testing as well. So Sensu is essentially an on-prem monitoring event pipeline, which collects, processes, routes, and different events such as discovery, availability, telemetry, and alerts. So Sensu can push and pull data in hybrid infrastructures to provide visibility into the health and performance of your systems. By executing Nagios-styled service checks on monitored nodes, it creates events that it can filter, transform, and handle. It also follows the monitoring as code ideology, so the pipeline is extremely powerful and 100% completely customizable. In previous talks, I've referred to Sensu as Nagios on steroids. I'm not sure if you're familiar with Nagios, the tool, but that metaphor really stuck, so hopefully that's helpful. But we'll dive into a demo a little bit later. Sensu Inc. is fully remote and 100% distributed company. Contrary to popular belief, working from home doesn't mean laying around and watching TV in your Snuggie all day. Although our dogs and cats do make occasional cameos in our Zoom calls, and we're free to run appointments in between meetings and whatnot, it's actually an incredibly efficient and collaborative environment. We have employees spanning all the way from Montreal, Canada, to Los Angeles, California, where I'm based right now. Our engineering team alone consists, it crosses several time zones, even international borders, such as Canada, but we haven't made our way over here to Europe just yet. But you may think that the work from home life can disrupt communications, especially when you're dealing with all of those different time zones. However, our work culture consists of swarming on design specs and implementation details, pair programming and debugging, and avoiding siloed work environments at literally all costs. So all of the problems we identified leading up to the Crucible actually had nothing to do with our remote status, but everything to do with our expanding knowledge of quality assurance. So now that you know what we build and how we operate, let's move on to how we build, test, and eventually ship our product. So hopefully this diagram looks really familiar to everyone here. Can I get a show of hands of who's seen this before in some capacity? I'm surprised that there's actually maybe 10-15% of you guys that don't have your hands up. But I would say it's a really popular diagram, and it's actually been released by a couple different people. People have different takes on it. But although it's fairly straightforward and considered by many testing standard, it's actually super applicable to our journey to the QA Crucible, because we as developers took it very literally. While there have been many different publications of this diagram over the years, Google gave their interpretation in 2005 when they released the blog post called "Just Say No to More End-to-End Tests." I don't know what kind of barbaric testing methodologies existed prior to this, but it essentially suggests a 70 to 20 to 10% split between unit integration and end-to-end test coverage, respectively. Placing emphasis on unit and integration testing encourages developers to practice and perform test-driven development. And just like the structurally sound pyramids in Egypt, this pyramid is thought to be a stable testing solution as well. Google also found that unit testing was ultimately faster and more reliable than its end-to-end counterpart. Due to the smaller scope of unit tests, they're also a much better candidate for isolating failures. So actually the only area where end-to-end testing reigns supreme is simulating a real user, because the larger scope allows tests to cover those real-world use cases that you wouldn't get maybe in a smaller scope test. So being very user-centric in nature, end-to-end testing can be incredibly significant, but equally as fragile. The language of Go and their framework allows us to write end-to-end tests, but we found that when running them on a per commit basis in our Circle CI, which is our CI pipeline, the tests were really resource hungry and they caused more harm than good sometimes. So much so that we decided to pivot our testing methodology to the one I've just described, that pyramid, and completely remove end-to-end tests from our CI pipeline. So that probably sounded super irresponsible, but I'm here to reassure you that end-to-end testing is not dead. It just didn't belong in our daily development workflow. So that's where DevOps comes in to figure that out, right? Sort of. If you're at a company with the bandwidth to support all three of these sectors, that answer is probably a lot more simple. But at Sensu, however, we're a young startup with a team of less than 10 engineers. 5 of us work on the back end, where 2 are dedicated to working on the front end. So we don't have a QA team or a DevOps person for developers to arrogantly hand our problems off to. Rightfully so, we have to clean up after ourselves. So our end-to-end tests ended up living with our QA process in a staging environment, which was already tightly coupled with our release operations. Not necessarily a great approach for continuous QA, but at the time of this decision, our general availability release was on the horizon. So that kind of leads me to the fun stuff, the good, the bad, and the really ugly of our pursuit of testing leading up to our GA release. So building software is easy, but don't quote me on that, please. Designing, architecting, specifying, and validating software are all a part of the development lifecycle. But if all of those processes are executed perfectly, actually building the thing can be pretty easy. Oftentimes when there's a buggy feature, it's not because the code is bad. I mean, in some cases it's because the code is bad, but it's usually indicative of a rushed design or a poor spec. Kim Goodwin had a similar take on Twitter. She said, "I'm convinced that a lot of technical debt is really problem definition debt. It exists because nobody took the time to define how the tool or the data would need to be used over time, even though many of those uses are easy to anticipate." I couldn't agree more, but I would also add in these instances, it's often because nobody took the time to define acceptance criteria, acceptance tests, or the definition of done. Without those, it's difficult to mark something feature complete. And especially as developers, we often kick that quality assurance can down the road, which is incredibly problematic in a startup culture where there's not much of that dedicated QA bandwidth. So we have an issue with problem definition debt, and we also have an issue with test definition debt, but unfortunately we can't declare bankruptcy on it, like Michael Scott. We just need to be more mindful and take initiative on being verbose in the early stages of development, even if those tasks have some product overlap. But again, say we do resolve some of that debt, executing the specified task is a breeze. So building software is easy, but shipping software is hard. What build and packaging tools are right for our application? How do we validate all of this functionality? How much of this process should be automated, manual? What even is quality assurance? How do we publish the final product to our users? When is it done? I can guarantee that the answers to these questions is going to be unique to each person and organization in this room. But because there's no one-size-fits-all solution to releasing software, you can imagine we experience some of those growing pains at Sensu. So releases should be simple, reliable, and reproducible. Simple and straightforward processes should be clearly defined and documented. reliable, cross-functional teams should all drive the same company initiative and deliver on time. And reproducible environments, workflows, and tests should help troubleshoot and debug potential regressions. However, this is what Sensu, or releases at Sensu, looked like for a good amount of time. If you've never seen the fire drill episode of the American version of The Office, it's pure and utter chaos. I used to actually have a clip of the video in here, but I kept getting copyright tags on YouTube if my talk got uploaded. So you can see Angela's throwing her cat through the ceiling. There's smoke everywhere. People are in total panic. They're trying to escape, and they forget the most simple safety fundamentals. While comedic, it's actually pretty relatable, because whenever there's a fire in the tech world, we get that like tunnel vision on a single problem or process. So before our QA revelations, releases at Sensu were complex, chaotic, and inconsistent. They were complex and mentally exhausting, with many manual processes, often taking 10+ hours from start to finish. They were chaotic, as communication between cross-functional teams was lacking, and we weren't exactly inclusive or understanding of why. And they were inconsistent, with process churn and tasks that were next to impossible to reproduce. I mentioned earlier that QA was tightly coupled with our release operations after we made that testing shift. This is because we decided that in order to have release confidence, we needed to perform end-to-end tests on all of our features. And if you also recall, end-to-end tests were no longer a part of our CI pipeline, which ran daily, because we just said no to more end-to-end tests. So without continuous QA or any stateful automation in place, this ultimately burdened all of our manual testing to release day. So as we kind of start to dive into some of the clunkiness of what our process for QA and releases used to look like, just please keep the following in mind. Some of it was bad, and we know it was bad, but we learned from it, and that's super valuable. We're at a really good place now. Some of it might be funny, and that's okay too, because in hindsight, many failures are very funny. And deadlines are a real thing. We had a product to build and business requirements to meet. We were heads down in development, mounting all sorts of technical and procedural debt. So we ended up gutting through a very painful process, much longer than we should have, because we just couldn't justify our engineering resources, which were already limited to begin with, to fix non-priorities at the time. But thankfully, the story does have a happy ending. I can gladly say that QA eventually does get treated as a first-class citizen. We just had to discover some things along the way first. All right, quality assurance. What is it and why do we need it? Let's start with what it's not. It's not quality control, which is more of a reactive means by which quality is gauged and monitored. Rather, the purpose of quality assurance is to prevent defects from entering the product in the first place. Regressions are the enemy, and test plans are your friend. We had humble beginnings with our test plans. Rather than thoughtfully approaching each feature of our product with a reproducible test strategy, like any reasonable QA engineer in this room would do, I hope, we instead got on a Zoom call, opened up a Word doc, and just started rapid firing a list of all of our product's features. Granted, this was very early on in our beta phase, but we completely skipped over any sort of planning session that would be required to thoughtfully produce this test plan. And this is a perfect example of that problem definition debt that I touched on earlier. We approached this session with an outcome-based mindset rather than analyzing how the plan might change over time, how it might need to change over the time. And that was ultimately detrimental to the beginning iterations of our manual testing. So here's an excerpt from our original test plan when it lived in that sad little Word doc. If you're not familiar with the concept of clustering, it's essentially just a feature where multiple nodes can work together as a single system. It's a critical feature of Sensu, designed for fault tolerance, high availability, and reliability over our embedded key value store, which we use etcd. I mentioned this because I'm going to be using this clustering example test suite a few times in my slides, so you can see the full evolution of the test plan. But as you can see, the steps aren't very verbose. Anyway, we would divvy up this work, and each engineer would assign themselves multiple sections to test. We would highlight tests in red, yellow, and green, sometimes other colors on the spectrum, to indicate a pass-fail state or the severity of the failure. Finally, we are expected to file GitHub issues accordingly and record them in a different section of the doc. A completed test suite ended up looking like this. At first glance, it doesn't seem so awful, but being manual, it was rather painstaking, and these tests were actually extremely vague. Front-end and back-end engineers alike were expected to verify functionality that they may know little to nothing about. These test suites didn't provide expectations either, hence the color spectrum of pass-fail statuses. Like, we don't know what yellow means, we don't know if it passed. And oftentimes it was unclear if something was actually working as expected because the expected behavior wasn't even defined. Eventually, this lack of explicitness in our test suites encouraged some developer bias. We were more likely to pick features that we were well versed in or that we wrote rather than those that would require some questions and research in order to test. Bias can play a negative factor when you're consistently QAing a feature that you wrote because you know how it's written and how it's supposed to work. Certain things can be overlooked due to your preconceived assumptions about the code, or you may be blinded by the happy path that you're convinced exists. Very similar to traveling down a treacherous river, Bird Box style. But introducing some cross-functional QA within our engineering organization mitigated some of that developer bias. We would have back-end devs QAing front-end features and vice versa. And it actually increased our awareness and empathy for the user. We were able to use our own intuition and interpretation of the product while still providing some valuable end-user insight. So, although those initial improvements we sought were great, we still recognize the value in our original process as well. We found that clicking until you break something is still a valuable form of QA, and it allowed us to find some edge case bugs and other design concerns with what some developers would have argued was already an intuitive UI. So those things you can't always capture with automated testing. I imagine our early stage QA parties looked something like this. Let's go conference Wi-Fi. Totally correct. So improvement number 1 was eliminating bias by adding instruction. Simple but necessary and actually totally overlooked in our initial iterations. Thankfully, as a team, we utilize retrospectives where we can discuss what is and what isn't working for us in a given process. If you're not already doing so, I highly recommend implementing this as a team practice. All of our process improvements that I'm going to highlight, including this one, originated as a problem in our retro, and after much discussion and collaboration, became a solution. So during retros, it became apparently clear to us that our test plan was not reproducible, which was extremely problematic. We decided during the next iteration of testing, we would document the steps taken to validate the feature in question. So after adding developer-aided instruction, we got to a sophisticated point in our Word document. Copy-pasted terminal commands for the tester to execute. Yay. While this was a step in the right direction, we still found that the Google Doc was difficult to maintain. It proved to have poor data persistence and virtually no historical data. This made analyzing regressions difficult without digging into our backlog or the source code itself. Google Docs has like a concept of object versioning, but we kept revisions of our template like separate from that, so that was difficult. And so we couldn't really rely on humans to reliably backport that data and track revision history. And obviously it caused some unforeseen circumstances. So take a close look at this test suite. This is an actual excerpt from one of our QA iterations. I have so many questions. What is a die and fig? Why does this backference backend need to come back? Like, how does this even happen? My brain hurts attempting to make sense of this, and especially as a tester, I just want to get through these tasks. But it's obvious that during one or potentially several of our phases, this text just got mangled. We got to a point where we were struggling to perform even the most simple QA tasks, and we were burning through valuable time before shipping GA. This was kind of the tip of the iceberg for us, like this test suite specifically, because I don't know, it was a little embarrassing to see that we had like let it get to this, but we realized that we'd been neglecting this process for far too long. So it was time to go back to the drawing board and give QA the love it desperately needed and deserved. Not only did we have data loss and maintenance issues, but the initial test plan was missing one of the most vital components of well-written tests, acceptance criteria. Sure, we could run all these commands in our staging environment, but what were our actual expectations for these execution results? After several QA discussions, we decided that we needed to revisit the test plan entirely. Our goals were to improve test coverage, validate our documentation through testing, and set clear acceptance criteria for testers. So this table-based model allowed us to do just that. The original test plan consisted of 13 suites and 147 total cases, whereas the new test plan increased coverage to 23 suites and 243 total cases. So that's about a 65% increase, just by being diligent with QA and formulating test scenarios from our user guides, what our actual customers would be expecting to do with our product. So being table-based, this made the long list of tasks much more readable and intuitive. Conditional formatting helped us highlight the pass-fail statuses, so responses were standard across testers. We didn't have that like color spectrum. And we introduced the concept of features, sub-features, and functions. So we described what a user should be able to accomplish and how they could accomplish it. Finally, acceptance criteria informed the tester on the expected behaviors of their invoked actions. So we increased our test coverage by 65% and clearly defined how to execute that testing, all in time for our GA release. But at that time, the process was still 100% manual. One of our engineers, Eric, originally coined the phrase QA Crucible in the same context as our QA parties, which is where we would just form and test. He was implying that the release candidate build must endure this so-called crucible in order to be considered viable for production. I'd like to believe he chose this terminology because our test coverage was just so thorough that our product had to be incredibly robust to make it through. However, the Crucible not only battle tested our product, but it also battle tested our people, like our engineers. Like validating 250 plus manual test cases was exhausting and time consuming, and we usually came out burnt on the other side. And once we got into that regular release cadence, we were losing about 1 to 2 days of engineering resources just to testing and releasing in a single cycle. But once we kind of realized that, we had an argument for cost effectiveness and investing in a better solution. So it was time to automate. Improvement number 3 is automate, but don't over-automate. Automation is every operator's best friend, but with great power comes great responsibility. I'd advise you to exercise caution in choosing when or when not to automate a specific task. It can ultimately save you time in the long run, but if used improperly, can be just as costly to debug. There's a certain threshold of complexity that should be capped in order to safely and consistently test in an automated fashion. You just gotta find the right balance. One thing that's probably safe to automate, your infrastructure. We use Terraform to rapidly provision AWS instances for our staging environment. It's written in Go, a language we're more than comfortable with, and we just so happen to have some extra AWS credits to burn through. This environment was already implemented and tied into our manual testing process. We just had to enrich some of those resources to cover the entirety of our test cases. Being able to automatically apply and destroy instances in a cloud environment in clean states was super beneficial to automating our tests. I can also add that very, very recently we implemented some configuration management into our stack. Ansible helps with our testing resource configuration and the configuration of our candidate builds. It deploys Sensu packages onto the nodes provisioned by Terraform, and it installs a set of resources which kind of live as our living test data. So by customizing the state of these pre-configured environments, we can run tests to assert the expected behaviors. After much research and consideration, we decided that our automated test tool of choice was going to be ServerSpec, a platform based in RSpec. RSpec is a domain-specific language written in Ruby, but designed to be a little more human-readable. When I heard Ruby, I initially suffered from symptoms of PTSD because writing and maintaining custom Ruby infrastructure at Apple was an incredibly difficult task. However, after studying the ServerSpec syntax, I appreciated how simple yet powerful it could be when paired with Ruby. It allowed us to run tests sequentially rather than in parallel, which was a plus for us, because for destructive tests, our cases that required like some sort of state change, this was crucial to be run sequentially. And being fast, lightweight, and simple, we decided that this library was for us. So in order to proof of concept ServerSpec, our goal was to write some smoke tests, or as our CTO Sean suggested, we call them vape tests. Is it installed? Is it running? Are these ports listening? Just simple verification steps to ensure that we have confidence in our infrastructure, product, and tests. Implementing these vape tests first allowed us to quickly learn ServerSpec syntax and validate that the most critical functions of Sensu were working as expected. So here's an excerpt of those ServerSpec backend vape tests. In a human-readable fashion, the Sensu Go package is installed, Sensu backend service is running, and several ports such as 3000 and 8080 are listening. When the script is invoked by a single command line, it saves the keystrokes of multiple commands. And at scale of nearly 300 test cases, those unused keystrokes not only are recovered time, but $ saved. The script outputs results as a documented report. However, the output format is configurable, so if you have a tool that consumes JSON, you can capture the results that way as well. We'll get into that a little bit later with Sensu. But we knew the Google Drive test collection strategy was not going to work in the long term, especially with where our automation was headed. So we had to find a tool to consume this data, which brings in improvement number 4, use a test case management system. Whether it's a monitoring event pipeline, a custom dashboard, time series data, an enterprise solution, we found that test case management was crucial to having a smooth QA process. Bonus points if that system is API driven for your automation. For our purposes, we ended up landing on TestRail, which is a modern test case management system. Does anyone use TestRail here? Couple hands. Do you like it? Oh, a lot of hands went down. It's a little finicky, but it did what we needed to do. But for those of you that use TestRail, I'm gonna blow your mind a little bit later with a different approach. After evaluating it and discovering that it had a simple API to populate test runs, we knew that this was the best solution to consume our automation at the time. You can see that it can display great overviews of test runs over time, which solves our concerns with data persistence and historical data. Our results were reliably stored as well, and so we could analyze trends and behaviors over iterative QA processes. Tracking bugs and regressions was also way easier with the GitHub issue integration that TestRail offers. You can both file and read those GitHub issues all without leaving the platform. And if you have a defect history, it lets the tester decide if the failure resulted from a bug in the system or a flaky test or a known issue. And what was even better was that our revamped table-based plan perfectly populated the TestRail template. So we were able to add some additional context to the specific test case that weren't present before, such as the type and priority and stuff like that. And we had to migrate the data once more to TestRail, but that can be done in an automated fashion. But once that data migration was complete, we exercised 1 or 2 iterations using TestRail with our manual test cases. And once we had developed confidence in the tool, it was time to pull everything together. So here's that same set of vape tests from earlier with one exception. It now specifies a TestRail ID. TestRail automatically assigns each individual test case with a unique identifier. And all that we had to do was find a Ruby tool that would publish our RSpec results to the TestRail API. Fortunately, there were many, but we used the RSpec TestRail gem. Aside from mapping each test to the respective TestRail ID and applying a small amount of rake file magic, this library that we used allowed us to configure and publish test runs directly from the command line. So we didn't have to deal with that TestRail UI. So I mentioned earlier that you shouldn't over-automate. This is still pretty relevant. Although this completed test run contains 100% of the results, about 30% of those derived from manual testing. We have several complex back-end tests that we opted to remain manual because introducing any like hackarounds would only make our QA ecosystem more fragile. We also still have a large gap between our front-end testing and automation, and that's something that we're actively investigating. We actually performed a spike on using Cypress to automate our front-end tests. So I'm actually really excited for a talk later today. I think someone's going to be speaking about automated functional testing with Cypress. If you're in this room, bonus points. I'll be coming to your talk. But it kind of leads into that last suggestion, which is hire employees with diverse experience. Like I mentioned earlier, my career started in quality assurance at Apple. And in ways, I was fearful that I would never be able to redirect my path in the future. Sensu, however, found DevOps experience just as valuable as developer experience. When I first joined the product engineering team almost 2 years ago, I was actually intimidated by the amount of talent and experience we had on our team. Every back-end developer had at least like 5 years of experience programming in Go, and I had 0. But we had really good teachers to help onboard me in that capacity. But because of that, when it came time to return the favor with something in my wheelhouse, I happily volunteered to lead the effort of QA. So my Ruby PTSD subsided, and I was able to dedicate my previous test automation experience to the QA Crucible. So the 5 major improvements that we talked about was eliminate bias by adding instruction, define acceptance criteria, automate but don't over-automate, implement test case management in any way, and hire employees with diverse experience. Not that these were the only aspects that we improved on, but they were certainly the defining factors to promoting quality assurance as a first-class status. So at Sensu, we're still far from being done. Our test plan will constantly be growing and evolving, and our process will always be improving. There are some use cases that our customers run into even now that aren't even accounted for in this process, so we're still working through those things, but that's kind of the beauty of being an open source or open core project. You have that tighter feedback loop with your customers because they can provide valuable feedback on regressions, features, and usability. We eventually want to get to a point where we completely decouple end-to-end testing and QA from the release process itself, so it can be performed daily or even per commit. And as we establish more credibility in our automation, we hope to get to a point of continuous testing as well. So since our GA release, we've shipped 14 minor feature releases with a number of patch releases sprinkled in between. So that means since the birth of the QA Crucible, we've spent months adding new features to our product and adding subsequent tests to our infrastructure, refining our release processes. This also includes challenging some processes we've maybe outgrown. Fortunately, these changes align with our goals of continuous testing and delivery. In order to be more agile, I kind of wanted to try to fast track our go, no-go decision that we would have on releases that would originate in TestRail, just seeing the green dashboard. But I kind of realized that there was a tight relationship with testing and monitoring. So tests fail, or they should, when an assertion in our code breaks. They aim to identify changes in a product's behavior before the users do. And monitoring, if done properly, detects and alerts us when our system breaks. If a system is unhealthy, there are usually warning signs that your monitoring tool should provide some insight into. So based on that last slide, we're able to develop this super advanced matrix. Monitoring and testing both relate to breakage in some way, whether it be your infrastructure or your product. But how does monitoring and testing relate to each other? In our case, it's state. By monitoring the state of a pre-configured environment, we can run tests against the expected behaviors. And by transitive property, we're actually monitoring the product in addition to the systems which support it. Turns out this idea is not entirely new. We had a Sensu Classic user that kind of adapted this ideology a little bit before, but you can essentially modify that server spec JSON output and feed that data back into many monitoring solutions, basically anything that can ingest JSON. So Sensu, being API driven and stateful, it allows the Sensu dashboard to visualize these test suites as critical or OK events. So I drew some heavy inspiration from this handler and rewrote it for compatibility with our new product, Sensu Go. And this YAML config you see up here essentially just tells Sensu where to retrieve the tarball required to execute the binary. So the workflow is compatible with containerized and ephemeral environments for that reason. So let's do a quick demo. We'll see this handler in action. I've had really bad demo experiences in the past, so in order to save myself a sacrifice to the demo gods, I'm going to play a video and kind of explain what's going on. So let's start the video. So here's a Sensu dashboard of our staging environment. With automated provisioning and config management, we're able to preload various Sensu resources. These resources are designed to interact harmoniously and create a certain state from which our tests can draw those assertions we were talking about. So let's dive into an example event called execution timeout. The event is failing and prioritized over OK events, and it derives from the check called execution timeout, which has a command where it sleeps for 5 seconds and cleanly exits. But the timeout is 2 seconds. So theoretically, every time that check is executed, Sensu should recognize that the process is still running longer than the defined timeout and kill it. So it changes the check output or the event output to execution timed out. So that's how the feature works properly. And all of those behaviors that I kind of described are asserted in our end-to-end test suite to validate that the feature works properly. So now on to the server spec namespace. Right there. It contains our testing infrastructure and configuration. So we have one Sensu check for each test suite that we want to run. Run agent spec executes a shell script right there to invoke a rake file for those server spec tests. And it's scheduled to run on a cron cadence every day at noon. The same goes for the run backend check as well. So for every new daily build, it will trigger tests against the backend server. Excuse me. And now, so this is the event output for the agent suite. So that's the payload that gets passed to that custom handler that I built. If I ever want to diverge from the daily schedule for some one-off testing, like you just saw, I can queue up an ad hoc check execution, which schedules the test to run immediately. So you can see that the agent suite ran just seconds ago, and the events should update soon. The handler explodes the high-level suite into multiple test cases, which you can see there. And now it looks like we are in the back-end test suite, which is rather large. So we kind of need to dive into each test failure individually. So you could see right here, this test failure is actually a known bug. It's a disabled feature on our product right now. Luckily, it's already tagged, so we can go ahead and manually resolve that because we're expecting the failure. So and the same goes for the other bug. So once all of those events are resolved, we can let that dashboard kind of inform a go, no-go decision on the release and ship it. So as you can see, we've effectively replaced test case management with monitoring, which can be quite an expensive tool. Sensu gives us that great overview of our test results, and but that also happens to be Sensu in our case is what we're testing. But by visualizing these test results in real time, the web UI can serve as a dashboard for both dev and test orgs. So whether you're using like the stateful UI that Sensu offers or something a little bit more traditional and explicit like TestRail, rest assured you're still prioritizing testing over quality assurance with either workflows. So some key metrics to highlight: we more than tripled our initial test coverage. We started with 147 manual test cases, and we improved to 454. And we decreased test execution time by around 66%. Earlier stages, it took around 4 to 6 hours, requiring like a lunch break in between to complete. And now we can complete all of our setup and testing within 2 hours. So coverage increased while runtime decreased. So achieving those simultaneously is actually a proud accomplishment. We also have some intangibles or unmeasurables. We decreased complexity by a lot, so we no longer dread those QA parties. And we increased reliability by a lot because we have a tighter feedback loop. We're able to identify regressions much quicker and much earlier in our process. So these things and more allowed our users to gain trust in our product and our QA abilities. So why are these important? NASA did this study to determine the relative cost of fixing errors associated with various stages of a product lifecycle. They found that fixing an issue at the beginning is between 10 and 50 times cheaper than leaving it until the testing phase is done. So having that tight feedback loop is crucial to the long-term viability and success of a project, and QA testing is just only going to empower that cycle even more. So in conclusion, invest in solutions early because it will save you time, money, and sanity in the end. So I think I ran a little bit over on the talk part, but we probably have some time for questions.
Thank you for your